Hello everyone. Today we'll talk about section 9.1, scale factors. As usual, homework is up here, and I'll post the blank notes and filled notes in the chapter 9 channel. Okay, so let's start with the definition first. Okay, similar figures. What are similar figures? Similar figures are two figures that have the same shape. Okay, they can be in different sizes, but the shape must be the same. Okay, so characteristic. Two figures are similar if the corresponding angles are the same and the corresponding lengths are proportional. So if the question tells you that these two figures are similar, then you know for sure that these two conditions hold. Okay, and the symbol for similar figures is this squiggly sign. So for example, if we have this, then that means triangle ABC is similar to triangle DEF. Next, we have scale factor. A scale factor is a constant factor by which all dimensions of an object are enlarged or reduced. Okay, and the formula for our scale factor is right here. Okay, so scale factor is image length over object length. And or you can say, oh, it's the image length over the original length if you have two images. Okay, next one, enlargement. Enlargement is an increase in the dimension of an object. So the image is greater or larger than the object. And so your scale factor is greater than 1. So let's think about some examples of enlargement in real life. For example, if you guys have learned science, and if you have seen a cell diagram, you can see that the cell diagram is actually an enlargement of a real cell, right? Okay, so the example I have here is two smiley face. This one is my original smiling face, and this is my enlargement, my image. And since the dimensions of this image, of this enlargement, is twice the length of the original, then the scale factor is 2, because scale factor again is image over object. Twice as large means image divided by object is equal to 2. Okay, so example number 1. Draw a enlargement that is twice as large as the original. So if this is our original, then how do we draw a enlargement that is twice as large? So let's look at this original diagram here. So you can see that the L has a width of 1 unit. Okay, so if our scale factor is 2, then that means our enlargement will have a length of 2 units, something like that. Okay, and let's see how long this is. 1, 2, half, and half. So it's 3. So from here to here, it's 3. Okay, what about this? Okay, so let's write down 3.5. Okay, and this length is about 2.5. And then this one is about 2. So let's draw it. Okay, so 2 times 3.5 will be 7. 1, 2, 3, 4, 5, 6, 7, and over here. And then 2 times 3 will be 6. So 3, 6. Okay. And we know that the width is always 2, double, so 2. Okay. And this is 2, so double will be 4. Like that. And then we have 2.5 doubled will be 5. So 5 right here. Okay, so this is our enlarged diagram. And here we use the graph paper or grid paper to draw the enlargement, but we don't necessarily have to use this grid paper. We can also measure the length of each side and multiply the length by 2 to draw the new diagram. Okay. All right, next one. Next one is a reduction. A reduction is a decrease in the dimensions of an object. So it means that the image is smaller than the object. And so my scale factor then will be in between 0 and 1. Okay, if it's greater than 1, you have a enlargement. If it's less than 1, you have a reduction. Okay. And what will be a real life example of a reduction? There are a lot. For example, a map. Okay, example number 2. So I asked you to use a scale factor of 0.5 to draw the reduction of this shape here. Okay, so this shape, we can tell that this is 2, and this is 1. So 0.5, a scale factor of 0.5, if you multiply by this, multiply by each length here, 2 times 0.5 will give you 1. So that means this length here, on my reduced diagram, will be 1. Okay, so let's draw it here. Okay, and this length here is 1, so if I multiply 1 by 0.5, then this side here in my reduced diagram will be 0.5 of a unit. So here, okay, and then 0.5, okay. And all the sides are the same. There are 2 units for each side. So I'm just gonna draw that. 2 units reduced by a scale factor of 0.5 will be 1 unit. So around there. Okay. So this is roughly what my new reduced diagram will look like. Okay, next one. Draw the flag of Russia using a scale factor of 0.25. Okay, so let's see. The width of this flag is 1, 2, 3, 4, 5, 6 units. The length is 2, 4, 6, 8, 9. 9 units. So if I want to calculate the length and width of my new reduction, then I'll have to multiply each of them by 0.25. So 6 times by 0.25 is 1.5, and 9 times by 0.25 will be 2.25. Okay, so if I draw that in my grid here, then it will be 1.5, and then 2.25, 1.5, 2.25, something like that. And then each of the color is a third of the width. So a third of the width will be like that. Okay, and if you want to color it white, blue, and red, there we go. Okay. All right, let's check out the last example here. Last example is determining the scale factor. Okay, so there are two methods to determine the scale factor. The first one is by looking at the distance between the center to each of the corresponding points. So for example, right here I have an object and I have the image. And if I connect the corresponding points on my image and on my object and extend the line, then all of these four vertices will meet at one point. And this point I call it a P. And this point is called the center. Okay, so method one is to measure the distance between the center and each of the corresponding points. So for example, from center to my point A, this is 5. And let me change the color. Let's use green. And from my center to A prime, this is 10. The distance between my center and A prime is 10. The distance between the center and A is 5. And we learned already that scale factor is equal to the image length over the object length. So same can be used here. We can use the distance between the center to image over the distance between the center to the object, and that will give you the scale factor. So our method one is actually we can measure that the distance between the center to each of the points, and the ratio will equal to the scale factor. So let me write that down first. So PA over PA prime. PA prime will equal to PB to PB prime, PC to PC prime, PD to PD prime. All of these will equal to the scale factor. Remember we said in the beginning that the corresponding length are proportional. Proportional means that the ratio between the lengths are equal to each other. Okay, so to find the scale factor for this question, it will be, we know PA and PA prime, so it will just be, oops, it should, it should be, sorry, it should be image over object. So it should be PA prime over PA, PB prime over PB, PC prime over PC, and PD prime over PD. So B10 over 5, which is equal to 2. So my scale factor for this question is 2. And that's our first method. And our second method is that we can measure the length of the corresponding sides and find the ratio. So for example, AC and A prime C prime here are a pair of corresponding side. A prime C prime is equal to 4 and AC is equal to 2. So using the formula for scale factor, we'll know that image over object will be 4 over 2, which is the same as the method 1, equal to 2 as well. So let's write that down as well. So each of the corresponding side, the ratio between them will equal to the scale factor. Okay. I'm just gonna highlight that so you know which formulas to use. And so for this question, we know A prime and B prime. A prime B prime is equal to 2. AB is equal to 1. So my scale factor is 2 over 1, which is 2. Okay, and we can check to see if our scale factor is correct. So we know it already that if scale factor is greater than 1, then you have an enlargement. And we can see here that our image is bigger than our object. So we have a enlargement. Okay, so that's it for today. Let me know if you have any questions.